All right, so let's take a look at the default configuration for the technologies that we've been using so far for communicating programmatically with the database, right? We have been using so far JDBC, and JDBC, the default configuration is that it auto commits, right? Meaning that if you do a select or an insert or an update using JDBC, it automatically starts a transaction for you, and then it will auto commit it right away. There is no mechanism for doing things that are a little more granular, where you might want to combine various operations like an insert with an update with a select, and then and be able to demarcate it and say, well, here's where the transaction begins. I will do several inserts, different updates, and they are all atomic, right? They all have to happen together, or none at all. Auto commit is the default, but we can certainly override that. You can set that to be something different than that, right? Where you explicitly say where the transaction begins and where it ends. So for instance, here's an example that you might if you're iterating over a result set that might have multiple records, multiple rows that meet a particular select statement. It might be that you don't want to commit all the changes until you are done manipulating all the result set, right? It might be that you're going through a set of records and you need to update each record. Maybe you need to select all the courses, right? And you need to iterate over them, and you need to change some attribute. Maybe make them from on ground. You want to change them all to online or remote, but you don't want to commit the result up until you are done, right? Because of the logic, you want to make sure everything. So anybody who might want to read the course and for updating on the website, you want to make sure that they're looking at the latest version, latest data. So if we're busy still iterating and updating all these records, right, we don't want people using stale information. So we might block other folks out from reading the database while we are updating. So we want to make sure that we demarcate instead of we update one record and immediately commits. We might want to wait until the entire loop is done, right? So we need to turn off the auto commit. Start the transaction at the beginning of the loop, right? We'll go through the whole list, and once we're done, we'll commit all the changes. Right. So in general, this is what you might do. You have two different statements, right? One of them does a select statement that retrieves all the courses, right? And they might come out, I don't know, a few hundred courses that the university offers. And as you're iterating over the result sets, the second statement might be an update, right? Maybe you're reading folks' feedbacks on the course, and we want to make sure that we wither out the courses that the students don't like, and we want to update based on the feedback. So here, for instance, we are. Am I being muted? No. Somebody's going to admit somebody. Okay. So for instance, we might want to update a course. Here is, for instance, we're deleting a course that folks have deemed to be a bad course, or whatever that means. So as we're iterating, right, we're removing the courses. So what we'd like to be able to do is see how is that the commits and the rollbacks, how do they behave by default. Like for instance, if you're doing an update, the update happens right away, right? If you're doing an insert, an update, a delete, that happens immediately. Whereas the select statement, the commit, the transaction completes when the result set, when you selected the rows, the transaction closes, right, when you close the result set, right? That you remember when we were talking about early on, we were discussing JDBC, that all these interfaces have their own close method, right? That you can close individually the connection, you can close individually the statement or the result set. And one of the things that I've mentioned is that make sure. Wait, somebody's calling here. Right, we have mentioned that the result set, we want to make sure that that you didn't leave any connections open, right? That as you ask for connections from a database and you don't release them, that the database eventually runs out of the connections. So we talked about a lot about closing connections, but certainly you can close also the statements. You can close also the result sets, and here's where it matters, right? That when you close the result set, the default behavior is that it now commits the transaction at the close of the result set. So the autocommit default of the transaction management of JDBC is not enough for when you want to do more sophisticated things, where you want a more granular control over the transactions. So, for instance, you would not be able to handle if the server crashes and you were iterating or you were updating something in the database. If the server crashes in between two inserts or two updates, it might be that one was successful but the other one wasn't, right? And right now so you would like to be able perhaps group together several updates or several inserts instead of them committing right away. You might want to have something a little more granular and do 2 or 3 or 4 updates together and then either commit them all together or roll them back. So by default, auto commit where you commit immediately is not enough. So for instance, we had an example that we discussed last time around about swapping 2 professors' sections, right? And so programmatically, you could do it as follows, right? Before we had done it at the command line at the console, but here's 2 command lines instances of statements that we are executing from JDBC. One is updating the professor Brando and Einstein. One teaches art, acting, and the other one teaches physics. And we want to swap the sections, right? We want to maybe add a section here or there, and their compensation is based on how many sections they teach. But imagine that we were doing 2 execute statements, and the first one was successful, like command 1 here was successful, but for some reason, right, either the threat went to sleep, or the server crashed, or for whatever reason, we're not able to execute the second statement, right? So we might end up with an inconsistent compensation package for one of the professors. So to handle this a little more granular, what you could do is that you can now you can use the set autocommit function to, for instance, turn off autocommit. Right, we can turn it on and off. By default, it's set to on. Yeah, it is autocommitting. If you turn that off, right, that means that the first time around that you start a command, an update, an insert, it will automatically start a transaction. But not until you explicitly call the commit function will it actually make the changes permanent. Or you can at any time just roll back and throw away all those temporary changes, right, and go back to the previous instance of the database, right, so that no changes make it permanent to the database, right. So for instance, here's an example where you use these functions. These methods are declared on the connection interface, right? You can call set autocommit to false or to true. You can turn it back on. And by default, it's on. So you turn that off, and then once you start communicating with the database, right, sending an insert, update, a delete, right, it automatically starts the transaction. And not until you call connection.commit, those become permanent. Then you either by your own logic, where you're verifying that the transaction was successful, right? Or if you determine somehow that the transaction was not successful, you can programmatically roll back all those changes, right? Calling connection.rollback. Or you can automate that and put that inside of a try-catch block that is going to catch all the various exceptions, and based on those exceptions, you can then call rollback, and then all the changes go back to where they were before. So here's a quick example where, in the previous example, where we were iterating over all the courses, and we don't want these update statements to happen immediately. Instead, we want to have control over when these updates occur. So we're turning off the auto commit. We are initializing the transaction by executing this first execute query. We retrieve the results that as we're iterating over it, we are temporarily making changes that would remove the bad courses, right, from the database. But these changes are not going to be made permanent up until we call connection.commit, right? And then those changes are made permanent, so that anybody who might be waiting for these waiting for these records to be permanent, right now they can be woken up if they were waiting on the lock. Right, they can be told to continue with their thread. So here's another example that we took a look at earlier. Right, we were discussing the idea that a couple of students, they gather resources, funds throughout the year, and they want to share it amongst all the students, and they were calculating how many students do they want to share it with. So they came up with, I don't know, like $100,000 at the end of the year. They want to share it with how many students are in the student body, and there might be 1,000 students. So they come up with, how many we're gonna divide it amongst all of us. So everybody gets $100, and so 100,000 divided by a count of students, and then we want to update the meal plan for all the students. But what happens if we are allowing folks to come in here and insert new students? So, for instance, in this select statement, we count how many students we were. If we have had the auto commit to be true, that means that this select statement, once we do the count and we close the result set, that's it. The transaction is over, right? We're not protecting the rows. We're not protecting the records. That means that somebody could come in here and insert more students, right? New folks who made it into the college. That means that in this update, right, we might be updating actually more or less records that were used originally to count how many students they were, right? So we might be actually depositing more money than we actually have, right? And depositing $100 into folks that were not counted originally, or maybe they were removed from the roster, and now everybody's getting a little more than $100, right? So we want to make sure that we're consistent when we're updating these things. So there you have it. So here's how you would make it consistent. You would turn off auto commit, and then at the end you can close the commit, and it will do the commit. You can also programmatically set the isolation layer so that you can automate how JDBC or JPA will handle transactions for you, and you can configure different isolation levels using, again, the connection interface declares all these constants. Right? You have read uncommitted, recommitted. Remember, these are all the solutions to many of the problems, right? So remember that read uncommitted meant we're not going to do any isolation. Everybody goes, right? Readers and writers can participate. We don't care, right? And this is the one that certainly produces the fastest performance, but certainly is the one that can have the highest risk and has inconsistency, because folks can be reading and writing. Readers can be reading when writers are writing. So the next one up is recommitted, making sure that if somebody is still updating data and they have not yet committed those changes, we're not allowing folks to come in and read that uncommitted data, which they introduce several inconsistency risks. Then we have repeatable reads, right? And finally, serializable. So you can configure all these things. Again, all these constants are declared on the connection interface, right? Connections set the transaction isolation, and then you can use all these constants. Transaction serializable. So they all start with transaction underscore, and then serializable is the the isolation level. Now, by default, the recommitted is the default isolation layer, right? Meaning, right, if folks are still haven't yet committed, right, any threads that might be reading that same information, they will be put on hold. Right, that's the default behavior. So here's an example of the meal plan, right? So actually, this is the I'm sorry, this is depositing $1,000, right? The student was withdrawing $50, and the parent was depositing $1,000. And so here, to fix that issue programmatically, we can turn off Autocommit. We can update the meal plan, meaning we are now in a transaction, right? And it starts off, and not until we commit down below, will we update the $1,000 and subtract $10. So we're not going to have any money lost in the various transactions.